let's do this. Let's review our long division first of all. Polynomial division. You guys talk me through this. How am I going to simplify this quotient? What goes where when I draw my division bracket up here? Numerator on the outside. Okay, good. So good. So we got the denominator on the inside. Remember, I have to keep a column for every power of x, but it looks like in this case there are no terms that are skipped, right? There's no zero coefficients. Oh, cube. And then outside we've got our x plus 2. Okay, next step. We do next.
So you would look at that x, see if it could, what it can go into that 2x to the fourth.
Okay, good. So I want to ask myself, how many times does the leading term outside divide into the leading term inside? So all we care about are the leading terms. The other ones we don't worry about. So we end up then, if we do that, we've got 2x to the fourth divided by x equals, what, 2x cubed? So that's our first term of our answer. Because really, if you think about what's going to be coming out of this, kind of look ahead a little bit here, we're going to get a polynomial part of our answer, right? And then potentially we're also going to get a remainder part of our answer. We may or may not get that. It depends if there's a remainder. Okay, what's next then? I got a new term on the top, so what do I do every time I get a new term in my answer? Okay, good. So we're going to distribute, aren't we? We're going to distribute that down to here. And that's going to give us our 2x to the fourth plus 4x cubed. Good. Now what? Subtract. And to make it really obvious that we're subtracting, we're going to put a negative outside and put the whole thing in parentheses, right? And then the way our eyes would scan the page when we're doing this, we would always do top term minus bottom term. So of course these cancel. They have to, don't they? That's why we picked that term up there. So those guys cancel. 3x cubed minus 4x cubed is what? Negative x cubed. And then the other terms, we're just subtracting nothing from them, subtracting 0, so they just come straight down. So I get my minus x squared minus x minus 8. And now we repeat, right? Just repeat the process. So negative x cubed divided by x equals negative x squared, right? So that's going to be our next term. New term appears, we distribute. So if I distribute my negative x squared, I'm going to get a negative x cubed minus 2x squared, and I'm going to subtract the whole thing, right? So again, these terms cancel. What is negative x squared minus negative 2x squared?
X squared.
X squared, because subtracting a negative is adding, isn't it? So we get our x squared, we bring these other terms down, minus x minus 8, and we move on to the next. Okay, so the next term we get leading term inside, x squared divided by x equals x. So I get a plus x. Got a new term in my answer, so I distribute again. If I distribute the x, I get x squared plus 2x. Subtract vertically. First terms cancel. Negative x minus 2x is negative 3x. Bring down the minus 8. And this will be the last one, won't it? And we can tell that because if you look at my answer, as expected, the terms in this polynomial are just stepping down, aren't they? They're stepping down by one every time. So we would anticipate that the next term I'm going to get is going to be my constant, right? And then I'd be done, okay? So what's going to happen here? Let's see, use that color. So if we divide negative 3x divided by x equals negative 3, right? So there's the last part of my polynomial answer. I'm going to distribute that. Got a new term, so I distribute it. When I distribute it over here, I'm going to get a minus 3x minus 6. And I have to subtract the whole thing. First term cancels. What's negative 8 minus negative 6? Negative 2. Okay, and that is my remainder. And I know that, recall, because now the power of the polynomial I'm left with, the degree, is less than x to the 1, right? X won't divide into this evenly, right? So I know that's my remainder. So how am I going to write my answer then? How am I going to write this answer? Let me do this. This worked well last time I did it. Oh man, I think this thing's about to. I gotta save it. I feel like it's about to crash. There we go. Okay, so now let's write our answer based on what we got out of our long division process. What's this thing going to equal? If I simplify that quotient, what am I getting? There's the polynomial part, right? So I'm getting it's equal to 2x cubed minus x squared plus x minus 3. And then I got a remainder of negative 2, right? So I'm going to end up with my remainder term that I'm adding. That's what remains over the denominator. So that's my answer. And I wouldn't have to do plus negative 2. I could just make that minus 2 over x plus 2, right? Okay? Good. Thumbs up, thumbs down, thumbs sideways. How we doing? Okay? That's a pretty long process, isn't it? Okay? There is, I'm going to show you a great shortcut here. It doesn't always work, but there is a shortcut for situations like this where we've got a linear denominator. Okay, so if the denominator, and this is not, you might want to, I will publish these notes today, but if you're keeping notes, like if you're moving along through the packet and taking notes, you might want to add this one statement to your notes here. When the denominator is linear, so what do we mean by that?
The x is just to the power of 1.
Okay, good. So it's a polynomial. It's a first degree polynomial, right? It's got an x term and a constant, and either the constant could be 0, right? When the denominator is linear and can be written in the form x plus or minus a, where a is just some number, then you can use synthetic division. okay? So here's how synthetic division works. When you're doing synthetic division, you make a bracket first of all. The bracket is different though. With synthetic division, you make the bracket like this. And you're going to put what used to go inside the division bracket is going to go along the top row of the synthetic division bracket, but you don't need any variables. You just need the coefficients. And I have to leave a column for every power of x, just like I do with long division. But I would just take these coefficients of the numerator and write them up here. So in this case, I'm going to get a 2, a 3, a -1, a -1, and a -8. And whatever the constant is, below the constant, I'm going to put my remainder box. Okay? So far, so good. Now, what goes out front? What goes out front is the 0 of the denominator. So what is the 0 of the denominator? If I set the denominator equal to 0, -2, okay? So I'm putting a -2 out front. And now I've set this thing up. All I have to do is my synthetic process, which I'll show you. So here's the process. You're just going to drop the first coefficient down. That starts the ball rolling. You drop the first coefficient down under the bracket, and whenever a number appears below the bracket, you're always going to multiply by the outside 0 and add it, not subtract. With synthetic division, it's always a process of adding instead of subtracting. It's the opposite of long division. So -2 times 2 is -4, and I'm going to add those to get -1. Okay. New number appeared below the bracket, so I multiply by the outside 0. -2 times -1 is 2, and I add and get +1. -2 times 1 is -2, and I add those and get -3. -3 times -2 is +6, and I add those and get -2. Okay, do those numbers look familiar to you at all? How about that? Those are the coefficients of the answer. How cool is that? So you see the connection? Look, we get our 2. Oops. There's our 2. There's our -1. There's our 1. There's our -3. And there's our -2. How cool is that? That's like 10 times quicker, right? So you can use synthetic division. You can always fall back on this if you meet these criteria, right? If the denominator is linear and you've written it in the form, the coefficient of x needs to be 1, x plus or minus some number, then you can always use this process, okay? So let's practice. Okay, you guys try that one. We'll go through it here in just a second, but try it first on your own and then we'll compare notes. Everybody get that to start their process? Remember the zero, right? Because we don't have an x cubed term, so we need to have a 0x cubed there. Is that what you got? Did I do that right? We get the same thing? So then what's that mean? What's my answer then? So this whole thing is equal to what?
X cubed plus 2x squared
Okay.
plus 6x plus 10 plus 19 over x times 2.
Okay, good. So how did you know what coefficient went with this one? I mean, what power of x went with this coefficient, this first coefficient?
You could just say that 10 is going to be, the 1 with no x.
Okay.
X and x squared. X.
That's a good way to do it, right? Sometimes you get answers that have lots of digits in them, right? Lots of coefficients. So you always just start, that the number next to the remainder box is always the constant. So then as you scoot over, that would be the coefficient of x squared, coefficient of x cubed, coefficient of x to the 4th, etc. if I kept going. So you always know where you start that way, okay? So we got x cubed plus 2x squared plus 6x plus 10 plus my remainder of 19 over my denominator, which was x minus 2. Because remember, the remainder is what remains over the denominator. Okay? Good? I want to look at one more example. So there's our answer. Okay? What about one like that? Okay, what's wrong with that picture there? The denominator, right? The denominator is not written in the form x plus or minus a number. Okay, so what could we do to this then to put it into that form? Suggestions. How can I what would be the algebra step I would need to do in the bottom of the fraction to make the coefficient of x equal to 1? Okay, divide by 2. Let's think of that in a slightly different way. Dividing by 2 is the same as multiplying by 1/2. Okay, and if I multiply the bottom by 1/2, what would I have to multiply the top by? 1/2, right? Because I can't change when I'm simplifying something. I'm simplifying this quotient. I'm trying to write it, instead of as one big quotient, I want to write this as a polynomial plus a small quotient, right? But I'm not changing anything. I'm simplifying. I don't want the value of this expression to change. I just want the way it looks to change, right? So if I don't want the value to change, does it make sense that I would have to, if I'm going to multiply by something, the only thing I could multiply that expression by would be the identity number for multiplication, which is 1. So in other words, whatever I do to the bottom, I have to do to the top. So if we write it this way, I want you to make sure you see what I'm saying here. So I'm going to take this polynomial that we're starting with. And I'm going to multiply it by 1/2 divided by 1/2. I've multiplied by 1 now, haven't I? So I haven't changed anything, right? If I distribute that 1/2 through, same thing as dividing the top and bottom by 2. You can think of it that way. But it's a little clumsy to think about dividing the top and bottom by something because it's not consistent with the identity number. which is a multiplying process, right? It's the same thing though, isn't it? Multiplying by 1/2 is the same as dividing by 2. In your mind, you can think of it either way. The result is the same though. On the bottom, I'm going to get what I need, which is an x plus 5/2. Everybody agree? I get a coefficient of x is equal to 1. On the top, what am I going to get if I distribute that through? First term is what? X cubed. Okay, if I distribute to the next term, I get minus 11/2 x squared minus 25x, good, minus. So that doesn't look great because those are fractions, but we can still do synthetic division with this. Fractions are just numbers, right? So let's go through our process. If we set up our synthetic bracket, then what are the coefficients that I'm going to string across the top row? First coefficient? 1, okay. Next? Okay.
-25. -27.
Okay, and then here's our remainder box. What comes out front?
-5.
We got it. Okay. So now we can just do our synthetic division process. So we drop the 1 down. -5/2 times 1 is, if I add those, I'm going to get -11/2 plus -5/2 is -16/2. What's that? -8, good. Multiply. 20, good. And I would just reduce first, wouldn't I? -5/2 times -8. Well, I would say, okay, well, the 2 and the 8 cancel and give me a -4 times -5 is 20. So I get a -5. And if I add there, I'm going to get -2/2, which is -1, right? Agreed? Okay, so then what's my answer?
X squared minus 8x minus 1.
Minus that, right? We agree? Because this is the quotient we were using for our synthetic division, right? Over -1 over x plus 5/2. Okay, that's pretty good, but that last term looks a little awkward. What would I do to that last term, maybe? Yeah, multiply top and bottom by 2, right? Why by 2? Doesn't that make sense? Because in order to set this thing up to do synthetic division, we multiplied the top and bottom by 1/2. So multiplying by 2 is just kind of reversing that and getting us back to our normal starting place, isn't it? We're reversing that process that we used to make this amenable to synthetic division. Now we don't want to leave a fraction in the denominator. So we just do, we're just going to multiply top and bottom by the reciprocal of what we multiplied by the first time. And that gives us our result, x squared minus 8x minus 5. That stuff's fine. That doesn't change. It's just this rational expression at the last term, right? We get this remainder term. Then we get -2 over, if I distribute that, I get my 2x plus 5, which is what I started with. Okay? And shouldn't that be the result when we divide this out? If we had used long division, wouldn't we have expected our remainder term to have a 2x plus 5 on the bottom? Well, this is just supposed to replace long division. Okay? So we should get the same result, which we did. Thumbs up, thumbs down, thumbs sideways. How are we doing on that? Okay. Then I'm not gonna keep you any longer. I'm gonna let you, there's the answer. I'm gonna let you guys just work away on this. So the same assignment, the second half of the assignment covers this synthetic division stuff.